Good afternoon, everyone. We are going to start this afternoon session, which is the Waste Reduction and Packaging Innovation Panel. My name is Kurt Lasko-Pooley. I am the Director of Programs and Development for Divert Nova Scotia. I want to thank Tyson and Stephen for giving me the opportunity to moderate this afternoon's panel. I think it's going to be a really good discussion. So first off, I'd like to introduce Dave Fox. He is a seasoned environmental scientist and efficiency expert who is the co-founder of Quantify Environmental. He co-founded that to help drive environmental sustainability in the industrial IoT sphere. Dave has a passion for sustainability and uncovering low-cost solutions to reduce operational expenses and emissions. His innovation and dedication has been recognized with the Clean 50 Clean Capitalism Award and the Clean 50 Emerging Leader accolade. So I'd like to welcome Dave to the podium.
Thank you, and thanks CFIN for supporting us to come out here. It's been a lot of fun to meet everyone. I think we all know the challenge at hand, and everyone who's come up here to talk and everyone who I've met is providing some sort of solution. So it's a really encouraging group to be around. And we're also providing a solution that I'm excited to share with you today. We work in the area of industrial IoT. This is a new and emerging technology that's now been fully proven out in facilities. And it's really exciting the impact it's having. And I want to share with you a bunch of case studies today and how you can use it in your food and beverage manufacturing facilities. I'm going to cut right to the chase. These are the feedback we're hearing from the factories that we're working with now. Immediate impact on their operational costs, immediate impact on their visibility. One of my favorite quotes, I told Tyson this would be more of an educational talk, so I took technology, put that in instead of quantify. But, he blurted it out in a board meeting, where has this technology been my whole life? He hadn't had this visibility for the last 20 years of his career. We were able to implement it in about 6 weeks. So for all the plant managers out in the room or anyone who works in a facility, can you relate to this? This is how we're seeing most of our analytics at our facilities right now. Analog systems, a lot of these are at Fortune 500, or a couple of these are at Fortune 500 companies. They're telling you how a multi-million-dollar piece of machinery is working that's consuming hundreds of thousands of dollars of utilities every year. And this is how they're seeing it. So obviously very low visibility. This is where industrial IoT comes in. So what exactly is industrial IoT? IoT is Internet of Things. It's kind of the industry term for basically taking all of the things we use in our life, all those hardware devices, connecting them to the internet and getting them to communicate with one another. So on a personal scale, you might be using Google Home, any sort of Apple product, that's IoT. When you start laying industrial on that, you're just building more robust pieces of technology that are specifically designed to work within the factory setting. The advances in the last 5 or 10 years have made these pieces of hardware truly low cost, non-invasive, and real-time analytics. So it's kind of cool how technology is changing policy, and we're seeing that a lot of the funding options or regions that provide funding that used to do audits are now shifting to funding these sort of projects because we're moving away from kind of spot checks to continuous visualization. It's quickly scalable. We'll typically install a couple sensors in phase 1, 20 sensors in phase 2. It's all wireless, so the old days of running wired data through your facility, running conduits, that's in the past. It's easily customizable. Software is magic. As soon as you get that data coming in, you can change it and make it look like any way you want it. And it's easy to deploy. So it truly is a hardware-software solution. That's a means to an end. Once we get that data, then we can start finding these opportunities, implementing them, and saving you money and driving down your GHGs. But on the hardware side, this is basically what a typical ecosystem looks like. So at the top there, you have your edge computer. That's pulling in all the data wirelessly from all your sensors throughout your facility. I just picked a couple examples there, air compressor, boiler water feed, water main. You can basically substitute any sensor in there. They're deployed throughout your facility and pulling in that data. So as a company, again, because this is a new technology, typically it's not a capacity within a facility that people know how to do. So Quantify, we're a turnkey solution. So we would come through your facility. Sometimes it only takes 2 or 3 sensors to truly find these opportunities. So we install them. We get the real-time visibility, and we make it all work on an easy-to-access dashboard. The reason we're doing this is multi-layered. First and foremost, makes you more competitive. A lot of plants don't have this. In fact, almost every plant I go into has very little to no visibility. It makes the whole team connected. So now everyone's looking at the same data sets. Finance is looking at the same thing that production staff are looking at. I know in the food and beverage industry, this one's really exciting. It's driving employee engagement. I know employment is very difficult in the food and beverage industry. And so it's really exciting to see a new graduate get this technology in their hands, and they see, oh, this company is engaged in new technology. I want to stay with them. We see that. But on the flip side, we see people that have been there for 20 years are kind of checked out. We put this technology in their hands. They start making changes to processes, and they see it in real time. It immediately empowers them. So it truly drives employee engagement and retention. As an industry, it's newish. Industrial IoT is only in the last 5 or 10 years that it's starting to be really embraced and kind of taking over those older SCADA systems. And what's really exciting for us to see as far as like market opportunity is in manufacturing operations. That's where we're seeing the most uptake. The other thing I hear when I go into plants is, we want AI to change everything that we're doing and make us more lean. And I say, well, you're filling out your boiler makeup sheet with a dull pencil. So, you don't really have the food that AI needs. You need to digitize everything in order for AI to take that data and do the real-time analytics. And what we're most excited about is predictive maintenance. So understanding when something is going to fail before it fails and reacting to that. So we work with quite a few companies. We like to expand much more in the food and beverage industry. We've had a lot of uptakes in plastics manufacturers, rubber, chemicals, the auto industry. But these are the companies that are embracing it, and within the first few weeks, they're seeing the impact it has. So we're excited to share some of the case studies from these different facilities with you today. So as far as like how it actually looks like, this is our base station. Every facility has one of these installed. This is where all the data from all the sensors is coming together. Talk to me afterwards. I can show you the rest of that video and what's inside. For a particular sensor, this is one example. This is understanding the flow through a hot pipe. So on the production floor, people can see in real time what that flow is. But that data is also being trended on a dashboard. So now you can have trending data. On the electrical side, amp loggers installed into any shutoff. We can see amperage draw on HVAC units, any major motor, air compressors, you name it. And I'll give you some case studies of how that's impactful. Once we get the data or the hardware installed, we then curate a live dashboard for you. So this particular company has multiple facilities across the country. Any of these hyperlinks can take them to a site in Quebec, a site in Ontario, and they'll be able to see a dashboard that represents that facility. When they scroll down on this, we always include weather data because that's impactful to your production and also shows we can pull data from anywhere. They have thermocouples throughout their facility. They can see real-time temperature in those warehouses to be alerted. Again, on the same dashboard, all in one spot, they can now have digitized water use on their main, cubic meters per day to see, or liters per minute to truly show how that plant is operating. We can then convert it into any data after that, any KPI, so dollars cost per day or cubic meters. On the same dashboard, you can quickly zoom out. Let's look at different time trends down to 6 months. So it's going to pull that data off the web. Now we can see a much bigger picture. And even with that, it's dynamic. You can start zooming in on very specific events. If something happened last week, let's look in and see exactly what that baseline flow was. If we jump over to another dashboard here, now we have much longer data trend. This is at a Stellantis plant. So we're seeing water use, and you can see it driving down from left to right significantly. The reason for that is they saw the actions they were doing to reduce their water use. Here we have real-time natural gas flow into a boiler. And again, the KPIs are super powerful. So in the last day, this is real-time data. We can see how many cubic meters they burned, what the cost was, and how many GHGs they emitted. Some of these boilers are emitting about 10 tons per day of GHG. It's pretty impactful. And then, of course, real-time trending of that natural gas going into the boiler. If we flip over to the electrical side, real-time view of any sort of air compressor, you can see how it's operating. I'm going to unpack this particular case study in a little bit. And they can see how it's operating day to day and the changes they've made and how it's being impacted. The last one I'll show here is how we can take that to the next level. So now they want to say, okay, we've implemented this, we've made some savings, make KPIs of those savings. And so we can say, since that's been implemented, they saved nearly 5,000 hours in maintenance time or run time, nearly $40,000 in electricity. Lastly, we can start putting alerts on this. So once you get this data coming in, your team can get text messages if the temperature's off, or you can get email reports of how this machine is actually operating. So that's the hardware and the software ecosystem built together. And so now I'm going to kind of unpack why we do this, the power it has. With this one example, we'll start with this boiler and how we've put in some different sensors, and then I'll move into some case studies. So this is typically how a boiler is looked at. No trending here, a different pen used every week. No one looks at this data. No one's really seeing how this boiler is using its utilities. So what we did is we started putting a sensor on the makeup water into this boiler, and it immediately highlighted an opportunity. Quite proud about this project. It's a plant close to my house. I go on hikes around here, and on the weekends, this boiler is just running all the time. So we started looking at the data, the makeup water going into this boiler, and we said, do you really need this boiler running on the weekends? So a lot of conversations. Ultimately, the solution was no, we can turn it off. So kind of to what Brett was talking about earlier, this whole idea of carbon neutrality versus net zero, they actually made an action. They didn't just pay for those carbon credits on the weekend. They turned off their boiler. The plant became net zero on the weekends. So small step, but huge savings. We then took that to the next level. We said, well, we're watching boiler makeup water go in. Now let's start looking at your natural gas. We just launched this 2 weeks ago. It's really exciting. We can see their natural gas burn every minute of every day. Once you get this data in front of this team and they realize how much they're actually spending on it, how often they're running that boiler that they don't need to, we start to see changes immediately. So let's jump into some case studies. I have 3 sections of case studies. The first of the 3 set is what I call kind of the home run case studies, or what we sometimes call the project payers, because this is the first opportunity we find at a plant. It typically finds enough savings to pay for our entire project within the first 3 months, and then everything else is in the black after that. So this is at a pharmaceutical company. Before we arrived, this was their baseline flow of water on their water main. And we realized, you shouldn't be using 25 liters per minute all the time, even on a statutory holiday when no one's there. But they were focused on making pills. They didn't look at their water bill. They didn't realize how much of an overhead cost this was. So once we saw this baseline flow, we thought, okay, we got to get in there. We got to help these guys. We got to eliminate this. So we went in and we found a failed solenoid up in the roof. We replaced it. And you can see on a Friday afternoon in July, that water dropped right to 0. We now have an alert on this, and we can see any time that peaks above that. In this particular region, they're paying $4.50 a cubic meter. That's $45,000 per year off their water bill. So pretty significant. Same but different plant. So this is, again, everything to the left on this graph is basically since the Big Bang until we got there. This is how they operated. They had no idea that they were running with a baseline flow of 25 liters per minute. This plant's in Guelph, where they're paying about $5 a cubic meter. So that was $50,000 a year. I went in the evening, checked out the boiler, and our team found a valve that was left on and flowing. And we turned it off, and you can see exactly when we turned it off. If we flip over to the electrical side, this is, again, another quick win for this company. This is how they're running their air compressor all the time. You can kind of see those little blips. That's your Monday, Tuesday, Wednesday, Thursday, and Friday. But again, drawing 50 amps all the time on the weekend. Pretty straightforward opportunity. Having a conversation with the whole team. Does anyone need compressed air on the weekends? No. So let's get someone to turn it off. So they started doing that. And now you can confirm, yes, this individual is turning it off every weekend. It's about $250 a weekend in electrical costs. That's $13,000 a year. The sensor to achieve this costs about $700. So paybacks are quite rapid. I always joke that this is a graph of my hairline from high school over to early fatherhood, from left to right. This one's really exciting. So now we're moving kind of the second stage of case studies. So now we've got the quick ones done. Now let's start looking at these longer term trends, and even this one's a bit of a transition because this is only 2 months. This is at Carlsberg. We put in systems that can now look at every subflow in their plant. And they were seeing, again, everything to the left is how they were operating before we arrived. The plant manager there was thinking, wow, we're using a lot of water on our flow of our bottle pasteurizer. So again, no cost solution. Started programming in a slightly amount of less water going to that bottle pasteurizer, still achieving pasteurization and all the specs there, but significantly reducing his water use. And again, this is only 2 months of data. So this project has paid for everything else we've done there. 30% use on this one. So he's going to start doing this on the can line pasteurizer and other places. Couldn't have done this without the real-time data kicking him and saying, hey, this is a lot, let's reduce it. Long-term trends, so on this particular project, we reduced their water use by about 40% plant-wide. This is a sensor on their water main. And it continues to trend downward. Really exciting stuff. Behind this graph is about 4 or 5 different projects. And again, that's the employee engagement part. They did one project, they saw the water drop, they got excited. They did another project, and they keep seeing that in real time. Here's a third one. This is at the Stellantis plant. So this is the one I showed you earlier on that live dashboard. What's interesting here, I'm not sure if you can see it where you're sitting, but we're going from about June to September. All of these savings were related to optimizing their cooling tower, so about 6 different projects. And again, back to that weather data, we know that a cooling tower has more water consumption in the hotter summer months, but we were actually driving that water use down during those hotter months. So we're really excited to see how this system's performing this summer, because again, now we have 2 years of data. The employee engagement part is also really exciting because all of those savings, the person who is involved with this project, who brought us in and entrusted us to do this project, she gets her bonus based on the amount of water she saves. So she can take this real-time data now to her manager and say, look, this is irrefutable data, this is what I've saved you guys. She gets a cut of that, and obviously that's a huge incentive to do this sort of environmental work. All those KPIs, they've all been updated since then. We've saved them far more than just $6,000. But again, those are rolling, updated in real time. This is also the data that your funding bodies need. We can quickly share this data with, for example, in this case, the city of Guelph. And they can say, okay, well, you've reduced your water use by 20 cubes a day. We can calculate that out to here's your incentive funding. You don't need to do a secondary audit, which costs money. You don't need to do a report. You just send them the data and you get your check. If we switch over to the electrical side, putting a sensor on another air compressor, basically every single air compressor we interact with, we find savings on. If you have a 50 or 100 horsepower motor running all the time, it's consuming a lot of electricity and it may not need to be. So again, everything to the left is how they were operating. You can kind of see that was over the Christmas holidays. So on Christmas Day, Boxing Day, January 1st, no one's at the plant. This air compressor is constantly chasing 125 PSI and running at 50 amps. Not needed. So we put this solution in, and again, $700 sensor, saved $14,000 in 6 months. Talking to the maintenance crew, they don't have to interact with this air compressor as much anymore because it's running 4,000 hours less a year. We did another, you can kind of see 2 opportunities there. Further to the right, the bars get thinner because we talked to the team and said, what PSI do you need? And they said, well, we only need 95 to run our diaphragm pumps. It was chasing 125, so let's knock that down even more, and they can track that savings. Now we get into the innovation side. So we've talked about the waste reduction, utilities, understanding how machines are operating. But because we have this visibility and there's sensors for everything, this is typically how our engagement with our clients go after about 6 months. We then start having these exciting conversations about, well, what else do you want to see? What have you never seen before? How will it help your GHG goals? How will it help operations or simply just drive down your overhead? But even more so, and I'll talk to it a bit more, quality control. We want to track temperature this exact amount all the time. In this case, they're having issues with their wastewater pH, so we put a pH sensor in their wastewater pit. Then we put a sensor on their water main. Now you can make these really cool discoveries with this data overlapped. Their pH is spiking when they're doing sanitation at night. What's that telling us about the overall operations? We can also take this data and quickly share it to their engineering firm that's redesigning their wastewater pit. That's no longer a line item on their invoice saying we had to track and do PhD studies because you're already doing it with Quantify and they've shared the data with us. So here's another one, quality assurance. So this is really cool, 100-year-old machine that we put 21st century sensors on, non-invasively integrated them, Now this particular dashboard is right beside the machine, and the machine operators are looking at this dashboard in real time. All those numbers across the top are updating every 60 seconds, so they can see exactly how this machine's operating, what the temperature of that product is. Beyond that, they take this data set and they mail it or send it digitally to their end customer and say, look, when we created your product, it was perfectly on temperature the whole time. If there's any defects, we have that basically blockchain data to rely upon. Then we can do some other really fun stuff. What we're starting to realize is a lot of plants with silos, they have no idea what's in them. Typically, they send a co-op student up a ladder and put a rope down to understand, which we couldn't believe that. So this is a trial. We did it on silo 1 and 11, where we see the most amount of movement. You know, we realized we weren't a real company until we were able to buy a drone. So we got some cool drone shots of this. And this is real time, so this is updating every 5 minutes. Any truck driver can come in, get on his phone, and see exactly what level and what SKU is in which silo. We're seeing a lot of runway with this, just with every plant that has product levels and silos or ingredients. So if I've got your gears turning about what can be metered, you know, like I say, we want to get in there, find you guys some money right away, get some savings engaged and tracked. But then we love having those conversations 6-9 months down the road. I've got this freezer unit, it can't go above 0. We need to monitor that and get alerts. We need to get reports on it. So yeah, I'd love to talk to you afterwards about things you want to see and how we can make your overhead costs reduce in your production. So thank you.
That's great. Thank you very much, Dave. I'd like to next introduce Mina Mekhail. Mina is the CEO and founder of Freshr Technologies. He has a PhD in biomaterials from McGill University and more than 14 years experience as an entrepreneur. He's a father of 2 kids under 5 who are keeping him young in spirit, but not so much in body. I think I can agree with that one.
Thank you, Stephen, for organizing this great event. Thank you for inviting me. So it is true that I do have 2 kids under 5, and someone lied to me a long time ago, and they said, kids keep you young. That's a lie. It's not true. All right, so that's not what I'm here to talk to you about. So we're Freshr Technologies. My name is Mina Mekhail. I'm the CEO and founder. So what is it that we do? Oh, the font changed. We develop sustainable active packaging to prolong the shelf life of fresh proteins, and we're starting with fresh fish as our entry market. So what is the problem? Across the supply chain, from fisheries and aquacultures all the way to the end consumer, 10 to 16 million tons of fish is wasted globally every single year. If you want to imagine what that number looks like, that's 4,500 Olympic-sized swimming pools filled with rotting fish every single year. Ton of waste. This is your packaging at the local grocery store, and it does nothing to extend the shelf life or protect the product. And that's precisely the product we look to disrupt. Our technology is called Freshr Pack. It's a coating that we apply on any film, really. We've worked with compostable film, recycled film, a whole array of films. And what the coating does is inhibits bacterial growth, reduces chemical spoilage, and reduces what we call free water in the package. All of these things working together will extend the shelf life of the protein, in this case salmon, by 15 to 30%. So salmon has a 14-day shelf life from harvest, if you keep it fresh, from harvest until consumption. So we're looking to get 2 to 4 extra days on it. This is some of our data that we just collected recently. You can see on the blue bars are the control packaging that is currently being used. The green bar is essentially a film that is coated with our Freshr Pack tech. And you can see that we actually reduce significantly bacterial growth over a span of 6 days. We decided to enter the market at multiple points. So we're not just entering the market in one specific area. Salmon, I'm going to focus on salmon because that's our first to market, is sold around the world mainly in bulk shipping. And in bulk shipping, the salmon fillets are sitting in boxes, styrofoam boxes. Usually they put some sort of a liner between the fish fillets, for easy handling. What we look to do is to actually go into that way of packaging and substitute that piece of film that they currently use with a sustainable product that can also extend the shelf life. I'll talk later about why that is interesting for people who are exporting. The roll is essentially our coated film that sits in a roll format, And that actually goes to the processors who are packaging in line. So either they are packaging skin pack, which is a hot topic now. I don't know how many people here are in the packaging space, but skin pack is very hot right now. Or if they are just doing vacuum pack on the product. And in order to do that with fresh salmon, again, if you're in the salmon business, you know that fresh salmon, if vacuum packed, needs what's called a 10,000 oxygen transmission rate. So a lot of oxygen needs to go through. This is FDA regulation that is required for US and Canada. And we've developed the first fully compostable, high OTR, oxygen transmission rate, alternative to what's available on the market right now. We can also make this product into a bag. And this bag is very interesting because this can be used in store at the retailer level in order to vacuum pack fish fillets. So the three main customer segments that we target, and I don't know how many in the room here are fish processors or work with retailers or film manufacturers, but these are the three main customer segments for us. For the fish processors, essentially when we extend shelf life, you can export further, you can capture new markets, open new revenue streams. You can actually cut down on transportation cost. So if now you have the extended shelf life that you can ship it via continuous trucking or via sea, then you've cut down that air premium that you're paying. But it's also important because most processors now are moving towards selling salmon as a value-add product rather than selling salmon as a commodity. And our technology gives that benefit. Finally, because it's a sustainable packaging that extends shelf life and reduces food waste, we have that added value of sustainability. To the retailers, it's a very obvious value proposition. We don't even need to sell it to retailers. And we've had conversations with a lot of them. Cut down food waste, capture that revenue. And I'll show you some numbers about, on how much that can actually be. For film manufacturers, if you want to add a value add to your film right now that you're selling to protein processors, we can also provide that benefit as well. So we ran some numbers with one of the major retailers in Canada, and as you know, there are 3 major grocery retailers in Canada that control more than 85% of the market. When we ran some numbers and we said, well, if we extend the shelf life of fresh fish by 2 to 4 days, and that can cut down waste by 50%, that is $37 million to that one retailer in Canada. Because fish is a high-value commodity, these numbers are quite significant. We've just completed building our first pilot production line, and actually Ingenuity was helping us there in Alf, back of the room. Thank you, Ingenuity. So we just finished building our first pilot production line that is going into our facility in the coming few weeks. And we actually, in the DNA of the company, sustainability is actually in our values. We have core values of the company. We call them CRISP as an acronym. It's, creativity, respect, integrity, sustainability, and perseverant passion. And sustainability is built right into our fabric. And we are sustainable because we reduce food waste, but also we reduce reliance on traditional plastics. And we align with the 2 UN SDG goals, 2 and 13. As you've heard earlier this morning, running LCAs is very important. We don't run our own LCA. We didn't run our own life cycle assessment. We've hired a company. I wish I knew about the companies this morning. I could have worked with one of you guys. But we've hired a company in the States that ran these numbers for us and showed that, unfortunately, because we're in Nova Scotia, our biggest contributor to greenhouse gas is the grid. Unfortunately. So if we move to renewable energies, we can actually have more of an impact. Even though we are still using the Nova Scotia grid, we are still reducing our net greenhouse gas. So the reduction in food waste is actually much larger than the energy that is used to produce our technology. And this number here, so around 3 kilotons of reduced GHG emission by 2030, and this number is only translating for a certain amount of film that we produce, but we're just doubled that capacity now. So we're going to be doubling this number, and we're going to be doubling moving forward. So these are our main competitors: modified atmosphere packaging. It's essentially immersing the protein in a mixture of gases that also slows down bacterial growth. But the problem with MAP is that it's very capex heavy, and it also requires change in workflow. In our scenario, we're providing processors with a film roll that sits on their packaging line that has no need for any retraining of personnel or change of workflow or any capex expense. Our competitors also include people who spray stuff on food to extend the shelf life. Now, if you're spraying anything on food, even if it's natural, we found out from talking to some of our major partners who are multi-billion-dollar companies that if you do that, this has to go on the food label. And if it goes on the food label, this has a negative customer perception. So we decided to actually move away. Our technology is a coating that goes on the film that does not migrate into the protein and only provides the added benefit when the film is in contact with the protein surface. So currently we're a small team, we're a startup. So myself, I have a PhD in biomaterials, as was mentioned earlier. We have a fractional CFO that's working with us, and a very strong technical team that is helping us get this to market. We've had a lot of people who believed in us from the get-go. So, a big thank you to all these organizations. We were based in Montreal for 11 years. We moved to Nova Scotia 2020. So it's been a few years now. And we, thankful for all these organizations. We've also won a whole bunch of awards, including last year's Halifax Innovative Business of the Year award, which was quite a big achievement for us. So thank you so much, and I look forward to talking to you after.
That's great. Thank you very much, Mina. Our final presentation of this session is from Beth Mason, who is the CEO of the Verschuren Center. Beth leads the Verschuren Center, an independent scale-up deployment center and CRO, helping primary manufacturing and new companies develop, scale, and adapt sustainable clean technology solutions. The center's key focal areas are industrial biotechnology, smart materials, renewable and thermal energy. Beth moved to Nova Scotia 8 years ago to build the bioprocessing program after working in fermentation of dairy derivatives for chemical and energy production with Saputo Dairy Products in Canada. Beth's varied experience in industry, research, and government and creating businesses has remained steadfast, focused on industrial problem solving towards sustainable solutions for the circular economy. As CEO of the Verschuren Center for the last 6 years. I'd like to introduce Beth.
Good afternoon, and I hope everybody's fully digested now and ready to get woken up. I'm going to run through our platform of product development, but in that, what I was thinking about, what are the take-home messages, and often those get thrown at you at the end when you're asleep, and so let's think about that at the beginning instead. The Verschuren Center's model is about getting more technologies to market faster. And to do that efficiently, what we focus on is a shared infrastructure. So I'm going to use our packaging project, thank you to CFIN as one of our supporters, and ACOA, who was one of our first supporters, as an example of how we can do that faster. One of the challenges we face in getting technology to market is the distance between that technology at bench and what our recipient companies are needing. We met with one group in terms of looking at packaging specifically with people like Danone and Pepsi, and the challenge there is a lot of times that demand for sustainable or biodegradable just gets passed down the line of the supply chain. So it's great to say consumers want, and from a manufacturer, a distributor, you're focused on, okay, well, that's what apparently we want. But when you get into detailed conversation with these companies, it's like, okay, which line do you want to change first? Which type of plastic do you want to modify? Which type of packaging? And do you want biodegradable? Do you want sustainable? Do you want recyclable? And it's different for every type of plastic. And I have to say, I'm not a polymer chemist, so don't ask me tough questions on that. But focusing on business development, you need to understand, number one, what it is that the end user requires in the context of now all the legislative framework on reusable, recyclable, and biodegradable. So we started this program some years ago, like a typical, R&D type process, but we very quickly realized that we need to understand the market. We have a great partner in Copal International who happen to be across the water from us in North Sydney, and they are a food film manufacturer. And food films come in an array of polymer types and layers. with various functionality added between those layers. So they're a nice partner in terms of let's test a whole bunch of different things together. So what we did was, and this is a challenge we were talking about last night, so-called biodegradable plastics came on the market a few decades back, and they were all supposed to be compostable. And the composters quickly learned that your PLAs at that time, which were the typical plastic, actually didn't compost in the time frame required and was still there at the end of the composting process. And so that really didn't help follow-on types of polymers. And so as much as PLA is still in the market in a lot of those single-use plastics and so-called biodegradable, the PHA, PHB market is now probably going to take over as that most likely candidate. That includes things like the high OTR films that were talked about by Mina. So the challenge you have with plastics is every market application, every product needs a different quality, needs different breathability, oxygen permeability, tensile strength, depending what its application is. Is it going to be wrapped around a salad and be a solid, semi-solid, rigid, or is it a film? And what we've tried to do is to say, what can we do in terms of incorporating biodegradability and sustainability into a range of those? And one of the reasons this becomes significant is we have a national plastics consortium of universities that are actually looking at end-use recovery. So as much as we'll do biodegradable, if that goes into compost, that's great, that disappears. If it ends up in the ocean, that's also not a problem if it is fully, truly biodegradable. But we're still generating a one-directional product line, where realistically what the Open Plastics Group are looking at is, of all of those types of plastics, including PET, when they get in the environment, it's not always a clean story. If we can capture them, and this is part of the challenge today, I think less than 10% of plastics are actually recovered from the waste stream. We have to change that. When that changes, then any technology that's going to allow complete circularity is going to be beneficial, because as much as right now that's a petrochemical circle, you can reduce. It's like your classic efficiency, isn't it? Reduce, recycle, reuse. So we've got to target all of those aspects. So we started with our little handy-dandy benchtop unit, which when they said benchtop, I thought they'd be kind of this big, right? But it really literally takes up the whole bench at the Verschuren Center. And what we have there is also, so we can make different films. So we looked at layers that give functionality. We looked at all types of elasticity, break strength, all those things, and we have all that capacity to do that. So if somebody comes to us with I have a new polymer for this application, we can very quickly test whether it works. So, these are just images of increases in elasticity if that's required, or decreases in break strength. All of that we can test, and improved antimicrobial function. So this was actually one of the films we were making in conjunction with Copal that had antimicrobial properties, which ties into the fact that it was mentioned earlier, I have my own company that's taking shellfish and fish co-products, because we don't call them waste because they're really valuable commodities, and upcycling those into functional molecules. One of those is chitosan, and that is a polymer. And so a big piece of our product line has been incorporating that in various blends and ratios to bring that functionality to other polymers. And one of those attributes is antimicrobial. In the middle of COVID, we actually had fun because we got some funding to do an antiviral package and coating experiment, because it was actually funny looking back on it. People were literally washing their groceries when they got them home. And so it's just like, well, why would we all be doing this? Why can't we utilize our antimicrobial properties in our films to coat those products, and then you're mitigating disease transmission? and finally could stop washing groceries. So it was quite successful, as you can see. One of our other test focus is true biodegradation. And actually, that's a bit of a misnomer in some ways, because you need your packaging to survive. I remember having one of these little shopping bags that was supposedly single use, but then biodegradable. And of course, I'm a bit of a pack rat, so heaven knows how many decades it was in the cupboard, but when I took it out, it simply fell to pieces. So it wasn't a very usable bag anymore. So the challenge with timing degradation rate is that it has to be under the right conditions to compost properly, in the right timeline, but you can't have it fall apart in the store while it's wrapping produce. So we've been working on blends that actually give us targeted and timed degradation relative to the application. So you can see it becomes very specific depending on the type of packaging. And that we've applied to a range of polymers. As I said at the beginning, it's not just a PLA, PHA, PHB. Also PET is one of the major issues in packaging. And so that's part of the program, is to see, and you can see on the pictures, over time during a normal composting, the key biodegradable ones disappear completely. So the other piece of what I said at the beginning, the take home, is how do you get from bench to scale? So this is wonderful in our little benchtop unit where we get a little piece of film and we can test all these things, but we now need to get that to a manufacturer, or from the bead manufacturer to the packaging manufacturer, and I can't do that with a little piece. And we remember we sent some samples off to Nate in Alberta to test for cheese packaging. And the strips were like this. It's like, can you do it around a tiny cube of cheese and give us some data on shelf life? And so like I said, the true take home is you need big plant to get your product into the test market. And so that was an obvious obstacle in talking with the large multinationals. And so we thought, why don't we ask CFIN if they'll help us support an infrastructure build around that? And thank you, they are supporting us. And this is the new packaging scale-up line that's actually going to live in Copal. It should have arrived in classic supply chain style now about 4 months ago, and is somewhere on a ship. We're not sure which route it's taking, depending on where the missiles land. So should be here any day, and that will allow us to produce big sheets of film of an array of applications and actually get them test deployed. So my point earlier being, you have to have scale to get to scale. And some of our partners in that are our packaging partners, our composting partners, and end users. So the circularity of the story, which I put in at the end here, because I feel like we were called the packaging and waste reduction. So I thought I'd put this piece in at the end. And it really ties together that circularity, and that is, even if we create those sustainable packaging solutions, we have to have collection capacity, and that's the focus of the Open Plastics Group, is if we can collect those things that are either biodegradable or somewhat more sustainable, can we reduce total plastics material consumption by bringing circularity? So they are looking, and this is why I have this in here, bugs are the answer to everything, as you heard earlier. They are focusing on the microbes, and it's a little bit like the Mara story, found on those plastics in the ocean that are not degrading rapidly, and then engineering those strains to be able to eat plastic, but also to degrade in key steps, because nothing's simple. Chemistry is never a simple straight line. Eat in steps so that we can actually pull the building blocks out of plastics and then reconstitute them. That, to me, is true circularity. The other piece of that is, as I say, microbes are everything. That, unfortunately, is not our plant. That's what our plant will look like. soon at the Verschuren Center, the industrial fermentation. PHBs are a wonderful plastic, but they have brittle crystallization issues, and that's what we've been working on fine-tuning so that they're more applicable. PHBs are produced by microbes consuming C6 sugars. And so we have a number of clients at the VC who need fermentation capacity to produce biopolymers. And so what we did is the same thing as on the plastic side, put in big equipment so that those companies can flow through, scale faster, scale more efficiently, as my friend Paul always tells me, cost efficient, and get to market quicker so you can produce big enough volumes to test deploy. And to me, as I say, I'm not a microbiologist either, not quite sure what I am, but certainly not an expert in chemistry, not a microbiologist, but the role of microbes in a circular plastic society, I think, is going to be key. So I will end it on that note. Thank you.
That's great. Thanks, Beth, and thanks to all three of our speakers. We do have some time for Q&A. Are there any questions in the audience that like the speakers to answer?
There's always many ways to get data, and ultimately we need to talk to the client, understand what do they need that data for. So classic example is water or airflow, understanding an air compressor. So when we talk about air compressors, sometimes clients say, well, we want airflow. Well, why do you want airflow? Well, we want to understand how the air compressor is working. So to answer your question, we could do a non-invasive amp logger on an air compressor and get the data that client needs versus an invasive airflow meter in the airline. That would be invasive. There's also a massive price difference. So it's understanding what they need the data for and what it's driving. Then we can choose the type of sensor. But overall, non-invasive, so what we mean by that is, thermocouples can be non-invasive. Ultrasonic flow meters in real time can be non-invasive. Amp loggers certainly are. I don't know the percentage, but the lion's share of our sensors are non-invasive because we also want to install them while the machine's operating. We don't want to shut things down. Sometimes that's not an option. And it'll immediately give us feedback. So I'll end with just saying most of it's non-invasive. Controls require wires. It requires a different legal team, different paperwork. You need to have direct communication with that machine to control. But we find that's fine. Typically our clients have nothing. So we get them to C first. That goes on for about 1.5 years. Then we get to the absolute max optimization of that machine. And actually, we're making that leap now with a company. They want to start controlling it. So we bring in a controls company. They start using our API. They start using our sensors almost become redundant at that point because then their controls have it. But we don't do that. But we don't need to.
I don't know if it's so much a question, but a comment to the packagers. We see the benefits and the carbon reduction, obviously, of protecting the product. We often deal with the end-of-life management of the packaging, and packagers across Canada are going to be paying $1 billion a year to run their curbside programs in the next 10 years. And so that means that you have to figure out whether your packaging goes in the recycling stream, the composting stream, maybe a diesel stream, maybe an energy from waste stream, such as Prince Edward Island. So when you're developing these products, is that something on your mind while you're thinking about those? Because often it's at the end of the pipe, and that's really hard to think about.
That's a very good question. As a company, we're trying to solve an issue. We also have to think about the end of life of the product. Compostable packaging, for whoever knows about compostable packaging, there's a lot of greenwashing that happened with the compostable space over the last, I would say 10 years. That made it very difficult for people to make any claims about full compostability moving forward. And there's also kind of mistrust with the BPI, which is the certification body that does the whole thing. And it's not looking very good for composting right now. But that being said, because my expertise is in materials. I'm a materials engineer by training. Yes, Unfortunately, there are bioplastics that don't degrade in the time frame that composters want them to degrade in, and unfortunately, when they send them off to farmers, farmers see pieces of, utensils and plates, and they're like, I don't want this. This is bad compost. Yes, that is truly a problem. But we can't throw out the baby with the bathwater. We really need to think about where composting is applicable and where it's not. There's no silver bullet. I was talking to Gary, who's on my table, about this earlier. There's no silver bullet. So my personal belief, and I think it can be done, but we'll need some education with composters, is that for specific applications, if it's a film technology, film usually has high surface area to volume ratio, it will break faster than a thick spoon or a plate. Depending on the composition of that compostable material, I think in the fresh protein sector, which is what I'm interested in, I think compostable, flexible packaging is the way to go. I don't think it's recyclable, and maybe people would disagree. I think anything that is soiled with food, like imagine you buy a piece of salmon that sits on a tray and has the film on top. You remove the film, it's already soiled with the salmon. You're not going to wash it with soap and water and then chuck it in. If you can even make it recyclable, because flexible packaging, as a matter of fact, 90% of flexible packaging is non-recyclable because it's multi-layered. So then if you want to make it fully recyclable, you have to make it monomaterial or mono-layer. And that's difficult because then you can't get all the properties that you want from flexible packaging. So I think flexible packaging can solve that problem, and it can solve it very well. And I'm a big believer in that, and that's why we push for compost. But like you said, it's a challenge. It will need some educating of composters in Canada and the States. In Europe, they're a lot more progressive than we are, but it will take some time to get there.
Thanks. Yeah, I see. We work a lot in energy transition and are mapping our path to net zero. There is no one solution fits all. We're in transition. We're in an energy transition, and we're in a plastics transition. We'll never. I say never. We don't need to get rid of plastics. We just need to do it better. And during a transitionary phase, our focus on development has been, if it lands in compost, if it lands in landfill, if it lands in the ocean, because we're aware that those collection systems don't exist right now, is it environmentally detrimental? So removing that aspect, regardless of the end location of it, is our primary focus. So, your point about multi-layered films is we'll replace the layer that's not recyclable with a recyclable or biodegradable layer. They're steps towards the end result. Digital sensors ultimately will be the way for recovery, where, you've got so many complexities, and you hear this from composters all the time. Too many different types of plastics. We don't know what to do with any of them, and they've got labels, and nobody cares about that. So realistically, rather than physically manually sorting, rapid sensor sorting would be the way to go, and that's introduced at manufacture. So that enables you then to differentiate the end use, whether it be for fuel use, whether it be for composting, or whether it's recyclable, recoverable, and reinstituted. But you can't say that today, because we don't sort plastics, that it's futile to try and work from a composting and a recovery standpoint. Digitization will resolve that at the right time.
That's great. Well, thank you again to Dave, Mina, and Beth for this afternoon's presentation, and thank you for listening to our session.